This hearing will come to order, and good morning and welcome to today's hearing on electronic waste. I would like to extend a special thanks to our witnesses, and today we will consider a draft legislation to establish programs to address the challenge of e-waste. Last April, the committee held its first hearing on this topic. We explored the challenges of managing the discarded old computers, cell phones, TVs, and other electronic products. These obsolete and inoperable products are being discarded to become what we commonly refer to as e-waste or electronic waste. As consumers move on to flat screen displays and the latest smartphones, older products are likely to be discarded by the millions. However, as I'm sure we'll learn today, these old products still have value. They either are still functional or they contain valuable materials. So perhaps terming these sophisticated products as waste is a bit of a misnomer. However, only a small percentage of these products make it to the e-waste recyclers. Most of us put our old electronics out on the curb or store them in the closet or dresser drawer. Perhaps the most egregious practice is the export of e-waste to workers in developing the world. There, the valuable commodities are stripped from the products and processed using primitive methods. These practices endanger people's health and pollute the areas where they live. This represents what I hope will be the first step at the federal level in addressing this growing crisis. As the committee learned last April, over a dozen states, local governments, and many companies have begun to increase e-waste recycling. And through the international laws and regulations, companies have removed lead, mercury, and other toxic materials from their electronic products. But the committee also learned that these efforts are not without their challenges, and much could be done better if we knew how to do it. The bill we are discussing today provides support for academic researchers to start tackling some of the barriers to making electronics greener. The recycling of plastics from electronics is a good example of where this type of research could make a difference. Current technology to sort plastics coming into the recycling plants cannot differentiate between all types of plastics. Plastic streams end up mixed, and the reprocessing plastics can no longer be used in high-value applications. This is a problem that can be attacked from both sides. Technology to sort plastics can be improved, and research can be done to figure out how to make mixed recycled plastics more suitable for use in new products. Creating more demand for recycled materials will make recycling more profitable and create less waste. This bill provides a mechanism for bringing together academic researchers and the industry partners. It is important that we are able to implement the new technologies to reduce waste and to manufacture products with environmentally friendly materials. And finally, the bill before us today addresses the need to educate both future and current workers. We need to get engineers thinking about green design of products and recycling. This should come central to the way we approach their jobs. To that end, the bill creates curriculum development and professional development opportunities. And with that, I look forward to the testimony we're going to receive today, and I now recognize our distinguished ranking member and my friend from Texas, Mr. Hall.
Thank you, Mr. Chairman, and I'm very pleased that we're having this very interesting hearing today. 63 years ago this week, the United States Army unveiled the world's first general-purpose electronic computer. I remember it well. And this electronic numerical integrator and computer, or ENIAC, was designed to be capable of solving a full range of computing problems. ENIAC took up to 680 square feet of space, weighed 30 tons, and consumed 150 kilowatts of power. We've obviously come a long way since February 14th, 1946. As electronic products have become faster and more reliable, they've also become more significantly smaller and more disposable. I just think that it's computer national ability that's hardly used by most people, yet still highly sought after in the marketplace. And advances in flat screen technologies have led to a new generation of televisions. With each new technological advance and model replacement, we face an inevitable problem of electronic waste. or e-waste. There are a lot of aspects to the e-waste dilemma: the definition of e-waste, reuse and recycling of electronics, landfill disposal and hazardous waste, regulatory issues and export economies. The EPA has already instituted several programs to deal with these problems. They include EPA's product stewardship, which supports stakeholder dialogues, pilot programs, public education, and international cooperation to foster coordination of electronics reuse and recycling. EPA is designed for the environmental program, which works with electronics manufacturers to incorporate environmental considerations into product design. EPA's environmentally preferable purchasing program, which helps federal agencies purchase environmentally preferable products. The Energy Star program, which promotes energy efficiency products through a labeling campaign, and EPA's WasteWise program, which challenges its partners to set goals for reducing e-waste. And I'm grateful to the chairman for circulating the discussion draft that we've had before us today and bringing this topic to the forefront. I'm curious to see how some provisions in the draft fit with existing programs already at EPA. Clearly, none of us want to duplicate efforts already underway as we try to effectively and efficiently deal with this challenge. I'm intrigued with a number of aspects of this bill. I'm hoping to get some clarification and hear our panelists' thoughts on a quote, green, unquote, alternative materials physical property database. Would this database replicate the structure and functions of the OSHA, EPA, occupational chemical database, or would it resemble the pollution prevention? What's that noise I hear? Electronic waste. Yeah. Or would it, I thought you was fixing to get the hook after me. Or would it resemble the pollution prevention resource exchange? And they write these things, and I read them, Mr. Chairman. I'm hoping that the highly qualified panel we have here this morning will be able to shed some light on some of the gaps in electronic waste research, and if the discussion draft appropriately addresses these shortcomings, it'd be good to know. I look forward to hearing from our witnesses today about this important issue, and I yield back my time.
Thank you, Mr. Hall, and your staff wrote some very good information there. We want to follow up on that. Additional members may submit statements if they have at this time, including records at this point, and I will submit one for my friend, the Congressman from the 1st District of California, Mike Thompson, who has been very active in this issue. He has a written statement that we will include. Now, Ms. Biggers, I understand you are on a short leash here today, and so if we'll now introduce the witnesses, and we'll begin with you.
All right. Thank you very much, Mr. Chairman, and thank you for the opportunity to introduce one of our witnesses to the full committee today. It is my pleasure to welcome and recognize Mr. Willie Cade, a native of my hometown, Hinsdale, Illinois, and owner of PC Rebuilders and Recyclers of Chicago. The final addition to our panel on electronic waste, his testimony promises to be both informative and enlightening from his career in recycling electronics. Since he founded his business in 2000, Mr. Cade has refurbished and delivered over 40,000 computers for use in schools and not-for-profit organizations. He was quickly recognized for his hard work and talent when he was selected as the first Microsoft authorized refurbisher in the U.S. Recognizing the growing prevalence of e-waste, Mr. Cade went a step further and co-founded the International Computer Refurbishers Summit, now in its 6 years since inception. With obvious hands-on experience, Mr. Cade is in a unique position to educate policymakers and the industry on the realities of mitigating the electronic waste stream. He has some terrific suggestions on research and collaboration efforts, as well as ways to increase consumer awareness and participation. So, Mr. Cade, we look forward to your testimony, and thank you for joining us today, and I yield back.
Thank you, Ms. Biggert. To help offset Dr. Ehler's intellect, we have a top draft choice here today, and I'd like to ask unanimous consent that Congressman and Dr. Rushholt from New Jersey be permitted to introduce a witness. Mr. Holt? or Dr. Holt, I should say.
Thank you. Representative is fine. Thank you. Thank you. Thank you, Mr. Chairman. And I am pleased to introduce, to commend, and to recommend to my colleagues here on the committee Dr. Valerie Thomas to talk to you today. I've known Dr. Thomas in a number of capacities over decades now, first as a stellar student in my electrodynamics course at Swarthmore College and a participant in my physics and public policy seminar. Later as a superbly active citizen when she and her family lived in the 12th Congressional District in New Jersey. Also as a fine musician and a wonderful mother. Dr. Thomas completed her PhD in physics at Cornell after graduating from Swarthmore, now serves as the Anderson Interface Associate Professor at Georgia Tech. Her research, among other things, looks at efficient use of materials and innovative ways to manage electronic waste. Over the years, she's conducted really outstanding research in a number of areas of interest to this committee. In addition to her excellent science, I think Dr. Thomas really exemplifies the potential for scientists to be involved in public policy in an effective way. A few years back, Valerie was a fellow, a Congressional Science Fellow of the American Physical Society, and worked as a staff member in my office. So I've seen her from a variety of perspectives, and she really is superb. Before her service in my office, she served as a lecturer at the Woodrow Wilson School of Public and International Affairs and as a research scientist there at Princeton University. She continues her commitment to bridge science and public policy as a faculty member now at the School of International and Systems Engineering and the School of Public Policy. Mr. Chairman, I recommend Valerie Thomas to your consideration today.
Thank you, Congressman Holt. Although you failed to mention that you're also the godfather to her children, and so for that reason you're going to be recused today. Also, our next witness is Dr. Paul Anastas. Did I get that one right? Close enough. Is the Teresa and John Heinz III Professor in the Practice of Chemistry for the Environment and Director of the Center of Green Chemistry and Green Engineering, the School of Forestry and Environmental Studies at Yale University. And Mr. Philip Bond is the President of Tech America. Now I would like to yield to our friend, Congressman Wu, for an introduction.
Thank you very much, Mr. Chairman, and it's my pleasure to introduce a fellow Oregonian at today's hearing. Mr. Omelchuk is the Executive Director of the Green Electronics Council located in Portland, Oregon. The Green Electronics Council oversees the Electronic Product Environmental Assessment Tool, which helps manufacturers and consumer market and purchase friendly, environmentally friendly electronic products. Welcome, Mr. Omelchuk, and I also want to extend a warm Oregon welcome to Mr. Bond, who is a graduate of and a trustee of Linfield College in McMinnville, Oregon.
Well, the West Coast is well represented here today. And as witnesses know, we try to limit our testimony to 5 minutes in terms of the spoken testimony. We have a copy of your written testimony already. So we will now start with Dr. Thomas.
Chairman Gordon and Ranking Member Hall and members of the committee, thank you for the opportunity to testify today. And also I would like to thank Representative Holt for his very kind introduction. I'm Valerie Thomas, and I'm an associate professor at Georgia Tech in the School of Industrial and Systems Engineering. It's widely recognized that electronics are not well designed for recycling. The valuable components are hard to extract and difficult to reuse. What is less well understood is that the electronics supply chain has not been designed for recycling either. The supply chain for making and selling electronics is a model of efficiency. managed with electronic data interchange, electronic manifests, radio frequency tags on pallets and cartons, and UPC codes on every single package. In stark contrast, the end-of-life supply chain is managed almost entirely by hand, with little record keeping or even potential for monitoring or oversight. That the result has included unsafe, polluting, and illegal activities at the end of life should not be a surprise. Electronics are just one example of the myriad products that consumers and businesses are increasingly expected to recycle. Major efforts to increase electronics recycling have brought the rate up to about 18%. Major efforts to encourage battery recycling, including the 1996 Mercury-Containing and Rechargeable Battery Recycling Act, have been even less successful. If electronics or any other complex or hazardous product are going to be recycled at high rates, innovation and creative use of technology will be needed. Electronics could have a standard label that would allow recyclers to identify the make and model of the product and manage its recycling or refurbishment. These labels could be something like UPC barcodes, or they could be radio frequency ID tags. In a small project sponsored by the US EPA, electronics manufacturers, retailers, and recyclers, and in fact, Willie Cade at the other end of the table from me and I are working together on this, are beginning to work out how to use RFID to make electronics recycling work better. Recycling rates for electronics are low because collection programs are difficult to use and because products are difficult to recycle. Products need to be designed for recycling, and collection programs need to be very easy, almost automatic, regardless of how complex the product is. Currently, consumers are mainly responsible for managing recycling. There have been efforts to make producers responsible for recycling. A third way might work better. Improve both product design and collection systems so that products can manage their own recycling. Rather than having to continue to work so hard to educate consumers about how to recycle each and every one of their purchases, products could almost manage themselves. For example, consumers could recycle electronics just by putting them in their curbside recycling bin. The bin could, or should be able to, automatically read the label on the product and automatically arrange for pickup. The recycler, or the recycler's computer system, would automatically arrange for resale or recycling, and the consumer would get a rebate for that item. Basically, the consumer would not have to do much of anything. The tag on the product would put everything in motion. Electronics recycling is important, but it occurs in a larger context of energy use and manufacturing impacts, impacts of recycling, and of reuse. Good recycling research is done in the context of all of the impacts of electronics and considers all alternatives. And I'd like to make one last point. Environmental problems are among the key challenges facing the world. Students want to solve environmental problems. Courses related to energy, environment, and sustainability draw students into the study of engineering. At Georgia Tech, our environmental courses are packed. Section 6 of the draft E-Waste R&D Act supports environmental training for engineers. This would not only help to solve environmental problems, it will also attract more students to engineering. Thank you for your attention, and I'd be happy to answer questions.
You should do what I didn't do, and that is turn on your speaker there, yeah.
I'd like to thank you, Chairman Gordon, and the members of the committee for the opportunity to comment on this this draft bill. My name is Paul Anastas. I am the director of the Center for Green Chemistry and Green Engineering at Yale University, and I offer this testimony on behalf of myself and my associate director, Professor Julie Zimmerman. I want to compliment the committee on the addressing this serious issue of e-waste, and the draft bill has many excellent provisions that I certainly endorse. The main message that I'd like to make to the committee today is really threefold. One is that if we're going to look at the issue of waste, electronics waste, it cannot be waste alone, but design throughout the entire life cycle of electronics. Second, that there are design frameworks that exist currently to ensure that electronics are able to be green and sustainable. And third, that through research and development, we're able to not only ensure that they meet environmental goals, but also economic goals and performance goals. So first, a few words about waste. When we look at the issue of how you design any electronic, it's important to know that looking at waste alone is not going to do anything for the manufacturers and assemblers and exposing them to hazardous substances. We know that in a typical cell phone, there are approximately 60 elements in the periodic table that are used in cell phones today, and focusing on waste is not going to address that issue. It's also of note that we only have reliable information on approximately 7 of those elements in terms of what our supplies are and what our usage is. So focusing on the design allows us to not only meet our waste goals, but also build in performance, build in capabilities, and build in profitability while addressing these hazardous waste substances. It allows us to ensure that materials that are used are benign, non-bioaccumulative, non-endocrine disrupting, and allows to get higher performance at the same time. The sustainable design frameworks. There have been principles of green chemistry and green engineering in the literature for some time that have been used across industry sectors. It's often said that the compass is more important than the speedometer, and that we need to know what the true north of sustainable design is. Just in the past few years, Presidential Green Chemistry Challenge Awards have shown that companies across industry sectors, from chemicals to plastics to polymers to pharmaceuticals to agriculture and yes, electronics, have eliminated enough hazardous substances to, according to the EPA, fill a train car hundreds of miles long. Now, they didn't do this because of a regulation or a thou shalt do green chemistry and green engineering. It's because you can meet environmental and economic goals simultaneously. So with all of these good news stories, with all of these historic accomplishments, that is good news. But the better news is this represents a fraction of the power and the potential of these green design frameworks. And for every one product that has been redesigned in this way, there are hundreds, perhaps thousands, that have not even been considered in these new frameworks. So the potential is immense, and one of the things that is absolutely required is fundamental research. I could list off the various areas necessary for dematerialization, such as nanotechnology, benign materials, alternative chemicals that are not persistent, bioaccumulating, and toxic, molecular self-assembly, but that is detailed in my written testimony. There are examples of very productive industry, university, cooperative research programs that can be used as models for this bill, including the Technology for a Sustainable Environment at EPA and industry-university partnerships out of NSF. I'd just like to conclude by saying that I view the fundamental research areas that I briefly listed as the bricks that make up the structure of sustainable electronics. The framework for sustainable design, the green chemistry and green engineering principles, are the mortar that hold those bricks together. The structure can only stand, can only be strong, can only be stable with both of these elements. That is the fundamental research within these sustainable design frameworks. That said, I'd like to thank you again and be happy to answer questions at an appropriate time.
Thank you for your testimony. And Mr. Bond.
Thank you, Mr. Chairman, and members of the committee and the staff for inviting us here today for an important hearing. I also wanted to commend the committee for a hearing that it held April 30th of last year on e-scrap, and would commend you the testimony of HP, which gave, I think, relevant testimony at that. I'm here on behalf of Tech America, and you may not know Tech America, but you know who we are. That's a result of a merger of AEA, the American Electronics Association, ITAA, the IT Association, and two others, which just last night, with Mr. Wu in our presence, unveiled the new name of Tech America, of this merger of four associations, which touches almost every state capital across the U.S., as well as offices here, Brussels and Beijing. So really a grassroots to global representation of the technology industry. Well, as Mr. Hall said in his opening comments, the technology sector has dramatically overhauled our economy. Even 10 years ago, if I had been here and mentioned companies like Google or eBay, that would have drawn a blank from everyone, and yet today they're ubiquitous brands. He mentioned the ENIAC computer, which filled a room, and today we wear on our hips more computing power than that had. Technology has also become a fundamental enabler, not just in the economy and innovation, but in the energy and environmental challenges facing us today. The industry is helping to lead the way in producing new and sustainable contributions. For instance, electric motors that use variable speed drives happen to be powered by chips from companies like Texas Instruments, and they're estimated to annually prevent emissions of 68 million tons of greenhouse gases. Recently, a study by the American Council for Energy Efficient Economy, concluded that high-tech electronics and widespread IT had been among the principal drivers of increased energy productivity over the last 15 to 20 years. And now the transition to energy independence will also include a reliance upon more of these devices critical to the functioning of energy systems, electric cars, and a smart grid. For instance, computer chips being developed by National Semiconductor improve the conversion efficiency for photovoltaic solar power. Smart grid technologies that allow two-way communications and thus less energy burned in the home or business. Migration to new computing models, you've heard of cloud computing, will result in a lower societal energy use for computing. Our industry has been a part of these, helping to drive these, and look forward to contributing innovation and advances in this area as well. Now, as we've gone about this, as the committee recognized, there has been a byproduct of the industry's growth in terms of e-scrap or e-waste, and we're actively working in that arena as well. Dr. Thomas has referenced the work going on to remove substances such as lead and mercury from designs. HP, Apple, and Dell, among others, have introduced notebook computers that use LED technology instead of mercury-containing fluorescent lamps. And such innovations, which continue nonstop, are notably and importantly almost always done in conjunction with our higher education system. The legislation being proposed by Chairman Gordon recognizes that, embraces that, and in our view goes a long way toward helping enable some real solutions. First, by authorizing the National Academy of Sciences report, because we've got to get the science right. Secondly, by funding R&D for green alternatives. And finally, requiring work with universities to improve the training of undergraduate and graduate students. And I just want to endorse what Dr. Thomas said earlier, what a great magnet this particular area can be for a new generation of students. I believe that the key will be the ability of the private sector to work with the leading universities. Merely funding the research is not enough. We need to make sure it provides concrete, implementable solutions that the private sector can use. There are specifics in the bill requiring academic institutions to partner with companies, to include participation by industry in the reviewing body that will evaluate proposals to ensure that they're practical. Applications must reference the companies and associations that contribute to a project. We think that collaboration is critical. And the application must include, importantly, transfer research results, again, making it relevant to the real world, which we think is so critical. We stand ready to be of an assist to the committee and the members in any way that we can, believing that more innovation is going to be part of the solution going forward. Thank you, Mr. Chairman.
Thank you, Mr. Bond. I think that we look forward to being a partner with you. You'll be a great resource. And now Mr. Omelchuk.
Thank you, Mr. Chairman. Thank you for holding this hearing on this important issue and for providing all of us the opportunity to testify today. My name is Jeff Omelchuk. I'm the Executive Director of the Green Electronics Council, a nonprofit based in Portland, Oregon, that works cooperatively with all stakeholders interested in electronics and the environment, from manufacturers to NGOs to the purchasers and users of electronics and recyclers, to try to realize the benefits of electronic products without saddling society with some of the negative aspects of it today. I'm also the Executive Director of EPEAT, Inc., which Congressman Wood introduced, and thank you very much. I wanted to highlight a few of the key issues I think that are emerging that make electronics rather unique product set. One, I think it's just striking that every advance we've made in society, nearly every advance in the last 50 years, has been enabled largely by information technologies. At the same time, they are the most impactful product on the planet to manufacture. This is a striking kind of situation for a technology. Recent research indicates that about 80% probably of the environmental impact associated with a desktop computer happens during the material extraction and manufacturing phase. Most of this impact occurs because of the chemicals and energy and water used in the manufacture of the product. The point is that these indirect materials can't be recovered during manufacturing because they're not present in the product. I think this argues for strong consideration of an end-of-life program that emphasizes reuse of these products and trying to do what we can to extend the life of these products as long as possible to amortize this impact of manufacture over a longer use life. So if e-waste only deals with the waste end, as it typically has in Europe, I think we're missing a huge opportunity to reduce the environmental impact of these products. Electronics are different than many other commodities that we think about recycling. If we think of beverage containers or other things, the goal of recycling those is to recover the material out of those so we can reuse that material, recover the aluminum, recover the plastic for reuse. The issue with electronics are rather different. I think our highest priority needs to be to prevent inappropriate recycling, as Dr. Anastas described and Chairman Gordon described. A lot of this material is shipped overseas where they make crude attempts to recover the expensive and valuable parts out of it, and their attempts have grave environmental issues associated with them. We need to prevent the export of our own waste where it causes these problems. Second, we need to, as a secondary priority, I think we need to keep toxics out of the environment. We need to prevent the pollution caused by e-waste itself. This is an issue that we don't face with, say, aluminum cans or plastic bottles. Third, we need to recover the high value and rare materials out of electronics. They're available often in quite trace quantities, but they're also very impactful materials to create and extract and make available in our society. So recovering those is probably the highest priority. And finally, recovering the plastics and ferrous metals, which is what we do mostly today in the small percentage that we do recycle, is probably the lowest priority. I'd like to further make the point that as Dr. Anastas did, that e-waste systems are incapable of affecting product design, and the product design greatly impacts the results of how well they're recycled, but just collecting the waste and recycling at the end of the stream does nothing to affect product design. And there are recycling systems, electronics recycling systems all over the world at this point. None of them affect product design. There's no incentive placed on the manufacturer to change product design to make them more recyclable. There is, however, an effective way to affect product design, and that's a green purchasing system, a specification placed by the purchasers of the product on green design. And there is a very powerful program in place today called EPEAT. It's a program that my organization manages. That is the program used by the U.S. federal government when they specify green electronics. Such programs do have the capacity and capability of affecting product design, or doing so effectively today. Today, EPEAT has created over a $60 billion market incentive for manufacturers to design and manufacture greener products. I'd like to make one input on the bill. The reason that we do not today have an electronics recycling program in the U.S. is because of difficulties with the funding system. Each funding system that has been proposed affects different kinds of manufacturers differently, disadvantages some disproportionately than others. Therefore, each possible funding solution is opposed by somebody, and that has prevented us moving forward collectively to have a system that works. Therefore, I suggest that in addition to the research proposed in the bill, that we also include policy and economic research in trying to figure out the funding system that will enable progress. Thank you very much for this opportunity to testify.
Thank you, Mr. Omelchuk. Just collaterally, you had mentioned the water in the process, and another major or legislative effort by this committee is going to be on water, and one of those elements of that will be research to how to use, in closed systems, and how to use water and reuse water more efficiently. Now, Mr. Cade, you're recognized.
Thank you, Mr. Chairman. It's an honor to be here today, and I particularly want to echo my fellow at the table, my fellows at the table here, in terms of their testimony. So I'm going to skip kind of quickly on to the recommendations that I would have in the legislation. First of all, in the definitions, I would suggest that there be very specific references to reuse, refurbishment, repair, remanufacturing, material recovery, and proper disposal. I think the current draft lacks some definition on that, and my experience has been when it's enacted into law, if those definitions aren't clear, it becomes very problematic. I would also suggest the definition of hazardous and potentially hazardous. I think that's one of the issues that really are hard for us to deal with in this particular situation. And I do want to let people know using their computers in the homes is not hazardous. There just is potential for hazard later on. In terms of the section for the research and development, in terms of part one of the things that we've been doing, I've run the collection facility for the city of Chicago on Goose Island, and over the last year, we've cataloged over 7,000 items that people have brought to us as computer waste. And of those, 3,000 different model numbers exist. With 425 different brands that those are made up of. The average age of that equipment is 10.2 years old. So that it's very important number there to understand is while we may want to design better product that's going to be coming down the road later, we have a large backload, large volume of equipment that we're going to need to deal with for many years to come. Our data suggests that the equipment is actually being stored longer and longer now that people are putting more and more of their valued data on that equipment. The other thing that I think is very important in this particular process is that we understand that this is not equipment that is not functional. It's just a perception that it doesn't work as well as the new equipment. And one of the things that we're very excited about is using these older Pentium 3, Pentium 4 systems to help homes monitor their energy use in a new smart grid environment. We're currently working with the Centers for Neighborhood Technology on creating product that will measure your home energy use and therefore be able to reduce your consumption. One of the things that we anticipate is by the mere savings on energy usage in a home, we will be able to finance the purchase of a PC for low-income families. Today, there is still 25% of the households that do not have a computer in them. If we can provide them a computer that can help them reduce their energy consumption, we believe we can finance not only the computer, a working model, but also that has all the bells and whistles, but also the internet connection and still save them dollars and energy on their home plans. And I believe that this remaking of the products, the remanufacturing, the reuse, the refurbishment of these products will actually give us the ability to bring home the electronics industry. If you're competing merely on cost per hour for production, we probably can't compete with foreign competitors. But if we are competing on a whole system of collection and use and knowledge and understanding of these systems and to bring product out, I believe we will be able to do a very, very good job with it. We're currently working on a pilot project in the city of Chicago where 100,000 homes will have smart meters. We'll be able to connect to those smart meters and be able to bring back information to the home user. Studies show right now that the home user who has that kind of information is saving anywhere from 15 to 30% of their home energy cost. Average home energy costs right now are about $1,200 a year. That's a significant savings. Thank you very much, and I'll be happy to entertain any questions.
Thank you, Mr. Cade, and we would appreciate your specific recommendations on definitions, and we would recommend again the committee or the panel any other recommendations they might have on our draft, as well as anyone in the audience or watching or listening to us on our website now. This has been a collaborative effort to get to the point we are, but I'm sure that as we have more people thinking and giving input, we can make it even better. So at this point, we'll now have the first round of questions, and the chairman recognizes himself for 5 minutes. Mr. Bond, you raised the issue earlier of the collaboration with the private sector and the universities and how that's going on now. I know that as this takes place, there's going to be some proprietary research. And is there going to be any kind of special provisions that we need in this bill that will provide incentives for the public sector and private sector to work together?
I think that that as a general rule, the federal government's role in doing a lot of the basic research, fundamental research, and very often through a grant structure where you have a lead investigator, a lead at the university who then invites private sector participation at a pretty fundamental level, is very good, and then allows for the proprietary innovations that might be built on top of that. But I think you will find a ready and willing partner in the private sector to do some of that fundamental research. New materials that could be incorporated into design, better uses or testing and research into uses of new materials that we haven't thought of before, technologies to recover materials. I think the industry has shown that it is on the edge of its seat and willing to
So you don't think any kind of special provisions need to be made for proprietary issues?
Well, we have some vehicles in the government already for cooperative research and development agreements and so forth that take that into account to protect intellectual property. But I think there's a great agreement that there is a first step where the government should lead and private sector is more than willing to participate.
On that topic, I think one of the biggest obstacles to national e-waste R&D initiative, like many things, is tech transfer and getting it from the academic research area into industry. So I'll just ask Mr. Bond if you want to, or anybody else wants to have any comments on how we can make that transfer better.
Just in some very general terms, I want to observe that I think the tech transfer laws in this country have been one of the great global competitive advantages we've had. As we try to maintain our global edge competitively, I think we have to constantly look at that because it's a competitive market, and other universities based in other countries are trying to attract investment from some of the multinational companies that do significant research. So I think we want to continue to look at that and would certainly welcome thoughts from those on the more academic side of the equation. But I think we need to have a balance in this, as we do in so many things, to make sure that as we divide the intellectual property, that it doesn't result in a stalemate, but it instead results in the tech transfer.
Well, let's ask anybody else on the panel. Mr. Cade?
Thank you, Chairman. I do teach at the University of Illinois, Champaign-Urbana, an e-waste sustainable class. And we are working on those. Also, the university has an international component to it. They have research centers outside the U.S. We're finding that their cooperation with us has been extraordinarily wonderful, and we are actually using students to take this pile of equipment and bring it back to life. We've already discovered, just through a few trials, some major issues that we need to input to our friends over here at EPEAT in terms of making this product more accessible for reuse and refurbishment.
Anyone else want to comment? Okay.
I would just suggest that there's existing models that have been used in various agencies to address this exact type of question. When we look at the the technology for a sustainable environment out of the Environmental Protection Agency, that's not only brought about excellent industry-university partnerships, but also sprouted quite a number of new businesses. If you look at some of the National Science Foundation models, the industry-university cooperative research centers, the engineering research centers, and science and technology centers, these questions of tech transfer and intellectual property have been dealt with well.
Dr. Bond, I know you would like to speak. I'd like to get on to one other question before my time runs out, too, and maybe if you want to help us with that one. The EU has taken more of a regulatory position across the board than we have in this country, although some states have. This bill really is in the research area. But are there any lessons to be learned from what the EU has done that would be pertinent to our bill in terms of not regulations, but rather research? Does anyone familiar with what they're doing over there or have anything they want to suggest? Yes, sir.
Mr. Chairman, the EU has completed twice now, I believe, comprehensive performance reviews of the WE system, the e-waste system implemented in Europe. They recently completed, I think very recently in the last few weeks, completed a second kind of comprehensive review of the system. So that is available to be researched.
Okay.
I'd recommend that we look closely at that. The other striking thing about the EU system, the two things that I would observe are that even though it's a regulatorily required comprehensive system, the actual rate of recovery of electronics is surprisingly low in the 35% range, which means it's still 65%, even though it's a regulatory required system, still 65% of the e-waste is leaving the system inappropriately, is escaping the system, which is a surprising number, I think, for many of us.
Well, that's why Mr. Baird is very interested in how do we, the psychology aspect of getting folks to work with the system. Anyway, and then my time is running out here. So anybody else want to comment on lessons from the EU? Yes, Dr. Thomas.
One lesson from the EU is that at least there's some kind of goal set forward by the government, and to move things forward in the United States, it might not have to be a EU-style program, but some guidance to push forward recycling and remanufacturing to because industries, it won't just be one industry that needs to work on this. Somehow there needs to be integration between the manufacturers and the retailers and the recyclers and university researchers, and EPA or some other government agency could provide some forum for making these organizations work together productively that won't happen in a vacuum.
It needs to be good, Mr. Bond, because
It's going to be short. I don't know
Okay.
about good. Just that there are a full range of stakeholders that should be a part of that discussion and part of that research. The government and its procurement rules, just to name one quickly.
thank you. Dr. Ellers.
Thank you, Mr. Chairman. And first of all, thank you for holding the hearing. This is a very important topic. I was watching 60 Minutes a few weeks or months ago and wrote a note to myself that I had to check into this. They followed a container of used computers, waste computers, some of them post-recycling supposedly, and followed it all the way to China, where it was simply burned on a trash heap after they had extracted some things. And yet everyone along the line specifically violated the law because they're not allowed to do this. So whatever we do has to have teeth and has to have enforcement. Secondly, let me say the minority regards this as a very serious issue and would be very happy to work with you on developing a really good and strong bill. I've looked at some of the options, and you've mentioned some of the options. I don't see any reason we can't do it. We just have to make sure we do it right, and we have to make sure we do it fairly. And any specific suggestions you have along that time would be useful. But before I go to you and ask for your comments on that, let me just ask a question, a generic question. What does the U.S. House of Representatives do with its used computers? When I was involved in computerizing the House for the first time in 94 and 95, we decided that any used computers from the House would be available for purchase by the employees who loved that. Many of them didn't have good computers at the time, and it got them in the home computer business, and we thought it was beneficial to the House too. Later on, we were told we were not allowed to do this because that was somehow giving a bonus to the employees. I didn't particularly worry about that, but it turns out, I don't know whether it was GSA or what who stopped us from doing it. But it's gotten steadily worse. We then proceeded in our district office, when we changed computers, donated them to nonprofit organizations. That lasted 2 years, and then we were told we couldn't do that either. I think we have to broaden our discussion to the GSA and what they are doing about this problem, because they have responsibility for a huge number of computers nationwide. And if we can set up a program that works for the GSA, it most likely will work for the nation. Plus, I don't think it hurts for the government to be first and find out what the burdens are on this so that we're not imposing unusual burdens on the private sector. We can answer their questions, say, well, we're doing it, this is how we're doing it, and it works.
Would the gentleman yield for 1 second, Mr. Ehlers?
Yes.
I faced this same problem in my office this year, would like to donate my computers to local schools, and have been prohibited. Jose Serrano, our colleague, has a bill to allow us to do just that, and I would encourage all my colleagues to co-sponsor that bill. It's ludicrous that we can't give our replaced computers to local education. I applaud the gentleman for raising the issue.
And I would even broaden it to other nonprofit organizations. There are a lot of social organizations that could easily pass these on to poor individuals who can't afford them. So that's my basic point. I hope we can answer the questions internally about what the U.S. House does, what the GSA does, and change that. Back to, I should mention, by the way, my wife will be very happy if we adopt a good program, because I cannot in good conscience throw out a computer now. We have 7 or 8 of them in the basement. and the basement's starting to overflow with that and my other junk. I'd appreciate any comments you have to, would like to, Mr. Cade.
Thank you. We have worked over the last number of years to try to get Executive Order 12999 changed so that refurbishers like myself can take the equipment from government agencies and distribute them. The issue really is around software and about the issue. In order to securely give the equipment to us, it needs to be, the hard drive needs to be wiped. It's tantamount to taking a engine out of a car and delivering the car to someone's driveway and saying, here, you've got a great product, have fun with it. We actually have, in the last 3 Congresses, had legislation to change Executive Order 12999 to allow refurbishers to get the equipment, then pass it on to the not-for-profits, et cetera. And I will be happy to take the equipment from your home. Oh, sorry.
Yes, Mr. Anastas.
I would just like to comment on your remark that we need to do this right, and comment on why it's so important to have sustainable design frameworks that allow us to do the right things right and not the right things wrong. What I mean by that is, so often we've seen good intentions for environmental and sustainability issues get it wrong. looking at our solar photovoltaics that are using toxic scarce metals, our biofuels that may not be compatible with our land use policies, our efficient lighting that may introduce toxins into the environment. So how do you ensure that you're not going to be doing the so-called right things wrong? And it's these design frameworks of understanding what the intrinsic nature is of the materials and energy flows that we're using in our electronics, not only what we make, but how we make it. And so that's why I come back to the compass being more important than the speedometer, and knowing that when you're trying to make something green and sustainable, that you're actually heading in the right direction.
Very good comment, and just a quick comment in response. Individuals generally do not look to the future as much as they should and analyze what can and should be done. And yet, you save money by doing it. And I was struck this morning, heard the news, once again, there's a lot of talk about the lead in the water in Washington, D.C., and the damage it's done to the children. This, every few years, this appears. The problem never gets solved. Kids continue to drink water with lead in it. And if you just analyze the cost of what that is compared to fixing the problem in the first place, I'm sure fixing it is infinitesimal. And I think you'll find the same thing with the computer situation. If you do it right, it's going to cost less in the long run than whatever we're doing now or whatever might happen if we don't do things right. With that, I yield back.
Thank you, Dr. Ellers. My daughter's been drinking that water. I'm terrified, and we do need to get some answers. If I could real quickly, as usual, you raised some very good questions, some of which aren't particularly in our jurisdiction, but let me try to respond. It's my understanding that Mike Thompson on the House side and Barbara Boxer on the Senate side is organizing a recycling effort, and that there will be a time where we can do that. The second thing is, as the former chairman of the House Administration Committee, why don't you and I collaborate and write a joint letter to the Speaker and to Minority Leader Boehner about those things that it may not be, what we can do administratively, maybe not legislatively, but administratively, and make those recommendations and challenge them to do that. So we'll work together on that.
Thank you very much. And if anyone wants an original Mac SE, I have one in my basement.
Okay, let's see. Ms. Johnson, you've been very patient. You're recognized for questions.
Thank you very much, Mr. Chairman. I'd like to pose a question to the panel. We have in some of our schools a program where computers are rebuilt by students, and they're teaching them to do that. Do you see any danger in that? Does that have to do with anything about restricting where they are circulated?
The actual process of the refurbishment is typically swapping out whole parts. So there's typically no danger associated with that. That's one of the reasons I recommended earlier that we put in the legislation a definition of hazardous and potentially hazardous. We don't see any, and we have been audited with environmental experts on those issues when we're refurbishing computers. We're typically undoing screws or unplugging things. We are not taking and grinding up the material to that end, and I am certain that that's not happening in the schools. So I with a high degree of confidence, would say that there's not any increased exposure risk to the students in that kind of a program.
Congresswoman, if I could add too, the upside of that, as a number of programs around the country have shown, is that it serves to demystify the computer to the kids and make them that much more willing to pursue a career in that field.
Yes. How can we leverage existing R&D that may be beneficial to solving the challenge of the e-waste?
If I may, there's a tremendous portfolio of research going on currently in green nanotechnology. Some of the leading groups out of the University of Oregon. There's wonderful work going on in biomimetic materials. There's wonderful work going on new types of batteries, energy storage, energy scavenging. That type of broad research is being done for for a wide range of purposes, but is directly relevant to the upfront design of next-generation electronics. By leveraging that existing research, there could be a real multiplier effect on the purposes of this legislation.
What is the rationale for exporting it? Is it for disposal or?
If I may, the rationale is really not, you know, it's not illegal or intentional activity by and large. So it's being exported to these places that you saw in the 60 Minutes documentary, or sort of, it's at the edge of legality. It's neither legal in China nor is it really legal in the U.S. So I think it's hard to describe the rationale. It's being done because it's mildly profitable.
Thank you very much.
If I could, Congressman, I would add that at least theoretically, and I believe in practice, there are examples too where someone would refurbish and then export what had been considered e-scrap or e-waste to maybe a developing nation or someplace where it would really be of use. And so you want to make sure, as you think of an international regime, that you don't somehow make that illegal because it was considered scrap, it has been refurbished and could be put to use in some other setting.
And I'd add to that the reality is that all electronics today or almost all are built in Asia, and if this is where they end up, there are very legitimate reasons to want to send the materials from which they are built back to Asia, because that's where they can be used by and large. And so there are legitimate reasons to do it. The challenge is to do it appropriately.
Mm-hmm. Thank you very much.
Thank you, Ms. Johnson. Ranking Member Hall, do you have any questions?
Thank you, Mr. Chairman. I was called away to an emergency meeting, and I don't know what questions have been asked.
Okay.
I had looked forward to hearing their testimony, and I'll read it at a later time, and I thank you.
Well, then
I
we'll
won't waste your time with a repetition of questions.
Thank you, sir. We'll move on then to Mr. Bilbrey.
Thank you, Mr. Chairman. I think it's important that we come back to certain terminologies that could be very, very damaging to this. Your reference to the hazardous. We've thrown that around, and we like to say that, and the argument, especially coming from California, is you always want to go to the extreme of safety to avoid any possibility of exposure on a lot of this stuff. And in California, we've seen what has happened with that. You can't walk into any store, any hotel without a big warning sign. The carpeting may cause cancer. That you know, basically people just turn off and don't read it. But the definition of hazardous, you know, I served 10 years on hazardous review boards and on environmental health agencies, and the definition does matter, doesn't it? Really draws a defined line there.
Yeah, and I think it's important to make the distinction between hazardous material and potentially hazardous. And much of the problems that you see in informal recycling is the issues that they bring up using things like cyanide, et cetera. So it's in the processing that those are the real hazards that are coming up, or the inappropriate burnings and those kinds of things. So I think that's exactly right, and I would defer to your experience in terms of writing the legislation, in terms of making those kinds of points. Thank you very much.
Mr. Chairman, I just want to point that out because it triggers certain processes, and we got to be careful. And not to belabor, but give you an example. We had a great system where there was an entrepreneur who went around to all the shipyards and all the industrial places and took the sandblasting sand and used that sandblasting sand in an asphalt mix. In other words, recycled it, put it into a product, avoided having to go out into the backland and mine sand from riverbeds and stuff. And it was going into an asphalt or concrete where it was stabilized. But because the item was a waste product, it triggered a whole environmental oversight that outlawed his ability to recycle it. And it ended up having to go to facilities to be thrown away rather than reused, and all once virgin material was gone. And nobody meant that kind of thing happen, so we've got to be careful with our trigger going down. You have comment?
I'd just say that this speaks directly to the provisions in the bill for the physical chemical property database, that when you're looking at the substances and this determination of hazardous or potentially hazardous, you're looking at what are the intrinsic physical properties, chemical properties that allow something to be hazardous, allow it to be bioavailable. And those intrinsic properties are so essential in this database because separating the intrinsic nature of these substances from the circumstances, those about whether or not people are going to be exposed, is the difference between hazardous and potentially hazardous. So I think the provisions for a physical chemical property database is well-founded.
Just real quickly, underscoring the chairman saying we got to get this right, it's further complicated by needing to weigh other societal benefits. So originally in laptops we went to fluorescent lamps because it was going to decrease the amount of energy used. But then there are problems with fluorescent lamps because they have mercury. So would you have not wanted that societal goal met for this one? Now thankfully we're moving to LED technologies, which are going to be the next innovation, and will avoid a problem. As design for environment improves, the need for regulation hopefully will go down.
And the issue of exportation, exporting the material, the waste product, it is universal in recycling. And maybe one of the things we need to talk about is why we don't make it legal to do more reprocessing within the boundaries of the United States. Because I don't care if it's cardboard or if it's e-waste. The rule is ship it thousands of miles away, they will recycle it, come back up, increase the carbon footprint, and it becomes a real problem there. I think one of the answers, and I'm glad to see that Member Bond is interested in this too, is this issue of the federal government looking at purchases of materials and designing the e-material from the beginning to be recyclable so that you not only eliminate the waste problem, but you provide a long-term source of material for the next generation so that now you've engineered something to where you build it so with materials that then can be taken and used as a natural resource or a recycled resource for the next generation. There's a sustainable economic base. And that, I think I'm very excited with that. And that's, Mr. Chairman, where we get into an issue that in the air strategy we always call the technology forcing regulation. And one way to do that would be for us within our own purchasing and procurement. And as ranking member on procurement and government oversight, I'd love to work with this committee at moving that item one step further and setting an example for the next generation of e-recycling, and that is basically using it as the mainstream, not as a subsidiary of the source for material. Thank you very much, Mr. Chairman.
Thank you, Mr. Bilbrey. Mr. Smith, I apologize to you for jumping over you. Promptness should be rewarded, and we'll get to you right after Mr. Baird.
Thank you, Mr. Chairman. First, I want to applaud you, Mr. Chairman, for taking the initiative that Mr. Ehlers raised. It's tremendously frustrating. We're mandated to replace our computers because they fall out of currency with the current operating systems. And then we see local schools in our district and we can't give our computers to them. Instead, we have to transfer them and get them scrubbed, and it's crazy. And anything you can do to fix that would benefit our kids and make a lot more sense. I want to ask a few questions. My district has made a real effort on e-waste recycling, but I'd like to know something about what are the best practices and what do we know actually works. And I do a lot of work on my own computers at home, and just uninstalling a single program is frankly a pain oftentimes. Are there industries, so if you say, well, what are my obstacles? And I'm a pretty environmentally responsible person. What are my obstacles? One is it's fairly complicated to uninstall. Secondly, you just don't know what to do with the waste. You sit there with batteries or with an old cell phone, or I don't know how many old chargers I have sitting around that I don't even know what they go to. There's copper in there, and that's useful and valuable material, but I don't know what to do with it. So we have seen in other areas that the computer industry has done things to establish standardization. The USB port is an example. I mean, there are hundreds. They have these whole networks of people that work together. Are they doing anything to come up with standard procedures or mechanisms to facilitate this? For example, a well-hidden complete delete button that deletes every, that auto scrubs your entire computer for when the time comes to put it away. Standard mechanisms by which you could extract transformers or copper, et cetera. What's being done in that realm, and what are the best practices to help public citizens respond?
Mr. Bond, we actually have built into our refurbished computers the ability to do exactly what you're talking about, a one-button, well-hidden erase. We did it because we provide our equipment across the United States, and we provide 800 number support based in the U.S. for that equipment. And what we found is that approximately 80% of our errors that our users have are software related, not hardware. They will call me up and say, my computer doesn't work. And so after a few minutes, I will go through and I go, if you're willing to lose everything on your computer, then fine, I will reset that back to factory settings for you. And so you're absolutely right. We need to develop those. And our process takes about 20 minutes in order to completely reset the data. Unfortunately, what it doesn't do, because of the nature of the way software has been designed, it doesn't erase the information. It just loses the ability to find it. And so I agree with you totally that we need to have, or some way encourage, particularly hard disk manufacturer or any storage devices, one button, let's erase it all, and know that that's done. I looked into my drawer before I came today, and I have approximately 17 different USB drives with storage. I have no idea what's on any of them. I took a magnet and tried to degauss them. They don't degauss. I also, by the way, put it through a washing machine because it was left in my pants. The thing still works. So we've got lots of equipment out there. And if you look at the NIST special report 888 on erasing information, it's a much bigger problem. And especially since, I mean, I'm personally concerned about it because I do my tax returns myself on my computer. I don't want to change them out. And I understand. I think, by the way, that is the fundamental problem with e-waste right now is people just don't have confidence in understanding how to get rid of and they need to rely on people like me.
And you don't want to take the time. I've got several old Mac laptops sitting around. I don't know what's on them, but I don't want somebody else to find out what's on them.
Yeah. Well, and that's why it's so important, the work that we're doing with Dr. Thomas on RFID, individual identification of product, because that will give us a verifiable custody history that we can work on it, and it's the kind of things that we need to develop. And just back to Representative Johnson's point about the nature of this legislation has requirements in it that it's multi-departmental in terms of working on these research centers. That's an absolute must in my mind. Everywhere from the art and design, industrial design product, all the way through to the chemist and all the products that they're working with.
I'd like to respond also. I think Representative Baird, your first premise was that the House needs to obsolete our computers at a pretty rapid rate because they're no longer compatible with the new operating systems. And I think that's an assumption that we as a society need to look at pretty closely.
I agree. I didn't want to do this.
Yeah.
My former computer worked just fine. It now crashes with regularity. So I've paid more money to get a system that works less well, and then I can't recycle or reuse my prior system. That's pretty stupid.
Right. So I think that's really a fundamental issue and it was part of my testimony to encourage research in the amount of e-waste, hardware waste caused actually by software obsolescence. And of course, I think we all recognize that that's a very challenging problem to address with the hardware software industry. That scares the bejeebers out of them to have us looking at that. But I think it's something that needs to be looked at in the light of day and thought about. The other comment I wanted to make is you talked about design for end of life and how would we design these products for end of life. And I just wanted to return to the point that e-waste doesn't do that. However, there are developing research programs around design for end of life on electronic products. In fact, EPEAT, the system we operate, has probably the best criteria of any eco-label around design for end of life. And to be candid, it needs more research. We don't really quite yet understand how design affects end-of-life scenarios, and the challenge in the U.S. is that the actual process used to recycle electronics are all over the map, from a room full of guys with hammers to very sophisticated, processes. And so, how do you design a product to be recovered efficiently in each of these scenarios? That's an area for further research that I think this bill could support.
Thank you, Dr. Barrett. As usual, you hit a hot button. And Mr. Smith, you're recognized.
Thank you, Mr. Chairman. First, a couple questions for Dr. Thomas. In light of the fact that I think many recycling efforts are cost-effective, both long-term and short-term, both directly and indirectly, and when you mentioned that approximately 18% of electronics are being recycled right now, does that mean the first user is not the last user, or does that mean like the second user might be the last user as well?
That 18% is an estimate made by the US EPA, and that includes in that number both reuse and recycling.
Okay,
So
so
it's kind of an upper limit number. The actual number is less.
in that 18%, there, that might also
That includes reuse.
okay, thank you very much. And then furthermore, we know that there are certainly energy costs associated with some recycling efforts and reusing and refurbishing as well. Are there any organizations that collect the data on the energy consumption so that consumers might be more familiar with what might be a best practice?
Yes, university researchers do that kind of analysis. The energy use of products can also be directly measured, and I believe that in EPEAT's ratings for green electronics, energy use is included.
Okay, all right, thank you very much. And Mr. Bond, one of the things that I don't believe your testimony addressed is the rather patchwork nature of state laws and various approaches. And being a former state legislator, I advocate, flexibility. I think that we want states to be innovative, and by no means do we want to see a boilerplate approach to this. But what lines of research would you say are most helpful for your members to be able to comply with so many different laws, and what kind of approach might you suggest?
In terms of the infamous patchwork, I'd have to think a little bit about whether that question lends itself much to research, although you could certainly research the added cost and perhaps cost to competitiveness of some of that. We confront this as an industry in multiple arenas where you do have this infamous patchwork across the state. So at the same time, we're a federal system, and you need to respect that. So the industry has tried to engage where they can. It's one of the reasons why we as an association have most of the state leading tech associations affiliated with us, so that we really can work on that basis. So I think that's an ongoing challenge for us. I think the best solution is to look forward, to look for design for environment solutions, so that you stay a step ahead of the regulators, because ultimately, in this case, that patchwork, if you're reducing the need because you've really designed for the environment, then you don't have as much regulation. I think that ultimately we do want to make sure as a country we keep our innovation advantage. I think that's critically important in so many ways. If the chairman would bear a short analogy, it's kind of like Mr. Gordon is famously, I think, the fastest member of the House when it comes to the annual 3-mile race here. But at some point, if we put enough weight on him, it'd have to be in the form of a vest, because he's not putting it on naturally. But at some point, enough weight would allow somebody else to win that race. So we want to keep Mr. Gordon winning. We want to keep America winning.
Thank you. I appreciate your comments, and I guess I would reiterate the fact that many of these efforts, I think, can be very profitable, and I think that's good, especially in light of certain conditions facing our economy today. And having also served at the local level, where a small town in Nebraska rarely has a landfill, I did learn a lot in terms of what we can and should do, and we did do to extend the useful life of a landfill in a good, sustainable manner as well. So thank you, Mr. Chairman.
Thank you, Mr. Smith. And really, let me just say that I think the thrust and the basis of this legislation is to make recycling a profitable, business model for either the companies that Mr. Baum represents or others that want to do it. So that's what we want to do. We want to make this profitable. So it's not a burden. And the other thing, I'll just quickly, a side note, you talk about, as a state legislator, there's a sort of a life cycle that I have seen here in Congress, and that is that industry starts off by saying, you know, no regulation, no regulation, and then some entrepreneurial state will, you know, they'll do something here, and another one will do something there, and then industry says, oh, please regulate us, because they need to have that continuity. That's something you'll see over and over here. Mr. Lujan, a new member of our committee, is recognized.
Thank you, Mr. Chairman, and thank you to everyone that took the time to be with us today. I'd like to get back to some of the discussion that took place with the concern of exporting some of the toxic materials and the number of people that are sometimes exposed to these, especially because most of them are low-paid workers that are sometimes exposed to these. And I appreciate the fact that we've been talking about sustainable design frameworks, the challenges to do it appropriately, and the recognition of the physical chemical property database. But we'd just like to hear your thoughts on other accountability measures or standards that could be implemented within the e-recycling community to prevent this from happening.
I'd like to point out that there are actually laws governing the export of used cathode ray tubes. Those are the big monitors for TVs and CRTs. And there was a GAO report last year that concluded that those laws need to be enforced. So some of the legislation already exists. You might look at the CRT rule, and it may need to cover some other electronic devices as well.
I completely agree with the perspective that we have a large problem that needs to be dealt with today in e-waste. I guess the only point that I'd make is in the reason that the research, the innovations, and design for disassembly and new materials and new energy storage is so important is so that we know that 2 steps forward, and our current problem is going to be 2 steps forward and not 1 step back, that we don't keep on creating. As we all know, the rate of production of these electronics is not slowing down. And so that's why the design is so important in addition to the problem that we're focusing on.
And I would add, Mr. Lujan, just very quickly, that you will find our industry very much in support of strong international safeguards and a regime here to protect workers and the environment here and around the world. These things do get tied up in other international agreements, whether it's trade or others. And so, again, affirming the chairman's call for getting it right, there's some facets to the question, but you're going to find the industry supportive of your core goals.
Towards that end, the U.S. EPA just concluded back in October last year standards called responsible recycling. I was part of that stakeholder process. It took about 3 years to work through it. I think a lot of the issues are addressed there. There are some people who would suggest that they are not high enough standards. I suggest that what we need to do is implement swiftly those responsible recycling standards, or the R2 standards, and then continue the research to see what's next in those steps. What has been presented and what is now public documentation is really, really quite good. And I believe the Institute for Scrap Recycling Industries is going to be the first first body to have certification available for electronics recyclers. And quite frankly, we're excited about doing that. Hopefully that will come about by the end of the year.
Thank you. And Mr. Cade, specifically in your testimony, you also address, and we heard from you today, about how we could be utilizing some of the technology to support a smart grid application. And just to hear your thoughts again, just to expand that on a large-scale application on what kind of benefits we could see as a result of that.
Well, the smart grid by the utilities will allow utilities to control the grid to the home. In order to really take advantage of that smart grid and differential pricing, you're going to need the user in the home, the homeowner, or the the person in the apartment, to take advantage of that differential pricing or that deferred usage. And technology is an obvious answer to those issues. Also, too, is when this equipment is rebuilt and refurbished, it's U.S. jobs. And frankly, I'm worried about that right now. And I believe a perfect example of what we can do in terms of refurbished equipment is the coming 2010 decennial census. It's a relatively short-term project as projects go on the government basis. It will have relatively large volume. I think that if we made sure in the census that refurbished equipment was part of the equation, I think we can really see it as a demonstration project that would be very bold by the federal government to bring some real awareness that reuse is a viable option.
Thank you, Mr. Chairman.
Thank you, Mr. Lujan. Seeing no one to my right other than my friend, Mr. Hall, who's passed. Dr. Griffin, do you like to be recognized?
Thank you, Mr. Chairman. I think this is a very, very important discussion that we're having, and the manufacture of consumer products with known carcinogens is an interesting concept. And we recognize that that this is not only a great part of our economy, but we also recognize the danger that we see here. And even though we may ship them off to be incinerated in some other country, once they're in the air, we know they're on the way back here. And so small trace amounts of whether it be antimony, arsenic, brominated hydrocarbons, we recognize that 200 plus years ago, the first malignancy that we related to hydrocarbon exposure were the chimney sweeps in London with testicular cancer. We know that this is going to occur as these electronic products become more intimate, closer to our skin, our bodies, and even implanted into us. So I compliment the chairman on this subject because I believe that it has great ramifications for us, because we're not going to decrease the amount of these products in our environment, but we're going to increase them. And I think the safety of it is not just in recycling, et cetera. I think it has a health care ramification. Thank you, Mr. Chairman.
Thank you, Dr. Griffin. Now the gentlelady from Pennsylvania.
Thank you, Mr. Chairman. I apologize. I was at another meeting and missed most of your testimony. So my question is fairly basic, but are there any existing e-waste programs, either domestically or in some other foreign nation, that we can actually look at for its merit to further study, possibly to replicate at this point?
I would defer back to the responsible recycling standards that were set up by the U.S. EPA, and really look to those as the standard that we have today. But again, I want to reiterate that that we need more research, and that's why I applaud the chairman in this draft legislation, that we really do need to research and make sure that we do it right in the process. I mean, just a kind of an interesting aside, my carbon offset or mitigation for traveling to this meeting is refurbishing a computer. You refurbish one or two computers, it's the equivalent of taking a car off the road for a year.
Yeah. Yes.
It is the case that, deferring to Mr. Bond's numbers, that approximately 18 states now have electronics e-waste bills in place today. In addition, the best known international example is the EU has a program. China is in the process of emulating that largely, not entirely. So there are a lot of models that can be researched, and I think it would be very fruitful to research the environmental and economic aspects of all those, and there's enough to research.
If I can just add to that, one of the things that's really interesting of those state models, there's only one, the state of Illinois, where reuse is actually included in the legislation, and there's actually concepts on that. I think one of the things that's the advantage of all of the states is we have a number of different experiments going on about e-waste, and the research is very important. I think when we talk to people, for example, in Oregon about their law, and we talked to them about reuse and how it was included in Illinois, they kind of went, oh yeah, we forgot that. So I think there's real fertile ground by the state's entrepreneurship, as the chairman represented, coming out with the legislation. And I suspect in a couple of years that we will be back here with the question of national legislation. And if we do our research right, we will have some very good answers and some very good understanding.
Thank you.
Just a quick comment. I think you are correct, and that's what we're trying to do is get in front of that to have the research, so when that inevitable likelihood of legislation comes up or regulation, that we can, again, try to do it right. Ms. Biggers, you'd like to close us out?
Yes, I probably could use a lifeline because I missed all the questions. So I'm sorry if I asked something that has already been asked, but and I'm sorry I have 2 committee hearings and 1 markup all at the same time, and I need a clone. Do you do cloning too? They're just computers, but I think what is important, is the recycling, and maybe Mr. Cade, you can just tell us. You probably told us one more. Just tell us one more time about how important the reuse is, and what is there anything that would be better, and what to do with our e-waste?
Well, again, thank you, Congresswoman, for your question. I think reuse really is the fundamental issue. The analogy I like to use is currently with our electronics, it's the equivalent of taking a loaf of bread and taking 3 slices out of it and then putting it in the cupboard, and 2 years later coming back and wondering why it's moldy and no longer good to use. We need to be able to make sure that people feel safe about getting rid of their equipment, that we have that standard set and that it's clear and it's transparent to individuals. And once that happens, then they'll start to bring their equipment out. And then we need to be able to have the database necessary to understand what's in that product so that we can figure out how to reuse it. So we need to build a complete infrastructure from scratch. It includes reuse, it then includes processing, and includes understanding of what chemicals, et cetera, are in there. That was, quite frankly, in the stakeholder negotiations on R2, it was incredibly difficult to try to parse out all of those different steps with the lack of data. So, Mr. Chairman, I encourage you, the blanks that I saw in the draft legislation were basically around the dollar amounts. I know it's a tough request, but I think money spent here will go a long way to helping our environment and helping not only individuals, but also all of what we do here. So thank you very much.
Yes,
If
sir.
I could just add to that, I completely support the what's been said about the recycle, reuse, and the imperative of that. We want to also keep an eye on design so that we make sure that we're not cycling materials through our society and our economy that are toxic, that are hazardous. The point that I'd like to make is that there is nothing about the performance of these materials, whether it's in a display, in a housing, in battery storage, that requires them to be toxic. There is nothing about the manufacture of an electronic that requires it to use literally thousands of times more material than actually winds up in the product. These are design challenges, and by taking on the basic research with the sustainability frameworks, we can change this equation.
Yes. Yeah, Mr. Omelchuk?
Thank you. I'd like to kind of add to Dr. Anastas' point and remind us that because the dramatic share of the impacts of electronics happen during their manufacture and their indirect materials, my point is it's a pleasant concept to think about closing the material loop on electronics. And if we could only recover them at the end, we could make new electronics out of the old electronics, and we'd be, that would be a nice closed loop. And the reality is that if we were to do that 100%, recover 100% of electronics, we would be recovering perhaps 0.1% of the environmental impact that was invested in manufacturing the electronics. So I think it's important just to keep that in mind, that closing the material loop is really not the goal, the overall goal.
About how, do you have any figures about how much goes into the landfill versus how much is recovered and reused?
There are some figures, but Dr. Thomas has a few, but quite frankly, those numbers I don't trust. We did a 2-week study at one of the 4 waste collection centers of the city of Chicago, and asked them to pull all computers that came through their garbage trucks. In other words, someone literally had put it in their garbage. We asked them to pull all the PCs out of there, and there was only 37 that came in a 2-week period for about 250,000 households. So it just doesn't seem like the numbers work on that. By the way, we did take one of the hard drives that had gone through the compression
I
of
wonder if it had been squished.
that had been squished, and we were able to read the information and who owned it. We looked up on the internet and we found the guy's address. So we were able to actually backtrack with that. So it's important stuff that we need to work on.
Congresswoman, if I could, I just wanted to underscore that many of the leading companies, give the example of HP, for instance, that have recycling programs, they do not send materials to landfills. So I don't want you to assume that everything automatically is headed for.
No, I was thinking more of the consumer probably is the one that doesn't know what to do with it.
I think Dr. Might have a rebuttal. So
Okay, Dr. Thomas.
Yes, Thomas.
Yes, no, I actually want to agree that we don't really know where electronics are going and how much is recycled. EPA tried to estimate this. They just pretty much have to sit down in a room with a piece of paper and make some estimates. We don't know where they are. We don't know how many are in people's basements, how long they keep them there. We don't know how many are sent to other countries. There's just nothing. When we know very well what goes through the manufacturing system, what is retailed, what's sold, and after that, it's just dark.
Okay, I've got a couple in my attic that are really old, and they're the old Macs with the little screen, and my kids used them, and I keep worrying about them being there. They're too old to be reusable, but what do I do with them? Just take them to the recycling centers that we have for the for electronics?
Congresswoman, I'll pick it up next weekend.
Okay.
I'll be in town. So.
Well, I'm going to have to dig them out.
Okay.
I got a lot in the attic. Thank you.
Thank you, Ms. Biggert.
Back.
And let me thank our panel for a very interesting hearing. And let me once again suggest that we are welcome to your specific suggestions. This is only a draft. Mr. Hall raised some very good questions in his earlier comments. We want to try to address those so that we can get the very best bill we can. This is an important topic. And so now the record will remain open for additional statements from the members and for answers to any of the follow-up questions the committee may ask of the witnesses. The hearing is now adjourned. Yeah, what's the, well, you know, Henry
complained to Waxman. Waxman said, that's interesting. Barnes fucking mad, he can't say it. He wants to go on the floor and raise it. I told him to ignore it. I have a philosophy, ignore the impossible and cooperate with the inevitable.
Well,
if he gets on those conference committees, he can't do that.
No, I'm just.
We just furnish the ass kicking. It's part of being in the